Okay, guys, I know that I keep blowing the 15-minute rule, and I did that in the last video. So I'm going to pay close attention here and try to get this done in 15 minutes, or try to keep these little mini lectures down to 15 minutes, which is really hard. Okay, so uh, let's try to get moving as fast as we can. So where we left off, we're calling the do something method over and over again from main game view every time that we did our while loop. And during do something, we would expect that something is going to change about what we're drawing. And then when we call the do draw method later on on our space creature, we expect that whatever changed during the do something method, that change should be drawn to the screen. And so how does that happen? Well, if you remember when you were drawing the creature that you've got so far, you would draw some sort of, alien or space car or something. And you had to draw all these like geometric parts. So if you look at mine, I'm drawing these lines. To draw the left and right arms up above, I drew the body, I drew the legs, I drew the feet, I drew the eye. This of all things in the class should be the most review to you, because you guys have mostly drawn your own creature, and so I'm drawing this thing. The thing that you'll notice that is different here than what you've done, we were hard coding all the numbers to the screen before, and typically when we program, a lot of this will almost never be hard coded, because we'll want to be able to move things around the screen really easily, and so we'd want to change these hard coded values to variables. Well, in this particular case, just for the example, most of the stuff is still hard coded, which means that my little guy is pretty much tied to this little position on the screen. But in the case of the leg, I've changed something. Instead of calling like the direct numbers, I am or sending in the direct numbers for the coordinates that I'm drawing. I'm actually changing these values to I change these values to variables. And basically, by being variables, that means that they can change while the program is running. And so my guy's leg, because these are values that can change while the program is running, this guy's leg can actually change where the screen, or where the Android OS draws it to the screen every time. And so let's look here. What am I changing? So my right leg, so my left leg is 65, and if we remember right, this is X, this is Y, on one point of the line, and this is X and Y, or this is the start of the line, and this is the X and Y for the end of the line. So if you look at this, the X doesn't change. The first X draws like at one point, and the first Y draws at one point, and because this is on the same X, we can basically go down, and we'll look at the example here. Where did it go? There we go. The X is like somewhere up in here, and the Y is somewhere up in here. Well, if we look at the right leg in the code example that I have, I'm not changing the x-axis, so it never moves, this way, because the x-axis sticks on 85. If we look at the code, there's 85 and there's 85. So that means on the x-axis, well, the x-axis goes this way, but since it doesn't change, it's drawing on a straight line up and down. And the only thing that changes is the top y coordinate and the bottom y coordinate. So, what does this do? I mean, and the question is, how does this change? Well, if we remember that we're calling this do something method over and over again, something must be happening in the do something method to change the value of his right leg position. It's the top y, and the bottom y, which is basically, if you look, that's the same variable in both places. So it's the same variable, just plus the length of the leg. So it's going to add, if we look in the code here, we're going to find leg length, and I've got that set to some set value. There it is, 65. So the leg is always 65 pixels long. So between here and here is 65 pixels, and all I'm doing to change the position is change one variable and then add the length of the leg to the second, or changing one y variable here and adding the length of the leg to that y variable. So these are exactly the same. This is the top y, this is the bottom y, plus the length of the leg. So let's go up here, and I should add also, leg length isn't going to change. As long as the program's running, I'm not changing this value. The leg length is always going to be 65. And I basically set just like a starting leg position. So when the program starts running that loop and draws the leg for the very first time, and you're right, so I set this basically the resting position, and then here I set the where it's going to start, where the leg is going to start, and where the dang it, that's annoying, and where the foot is going to start. So the do something method starts up, and we know that this is going to get called over and over again. Basically what I do here is I figure I have this last time variable, and all this last time variable does is record a time that the last time that it did something, because I don't want it doing something as fast as the computer is capable of doing something, because if I did, things would change so fast that you wouldn't even be able to see it. So I need to like slow down how fast things change. So when I start up the program, the very first time, I just set this to the current time, and that's basically what this little method here. I won't go into too much detail about what it means, but basically this is getting the current time in milliseconds from some like crazy time. If you look at this comment that pops up, it says since January 1, 1970. So this is the number of milliseconds. Whenever you call it, you're going to get the number of milliseconds since 1970, which is just a kind of a crazy concept to me. But in any case, I set it to a current time, and then when do something gets called, it gets the current time as of the point that it's running, and it looks to see first if last time is greater than now, and that's just because I set this little extra 100 on here, and I don't really want to go into it, but it basically gives the computer time to sort of initialize before it draws for the first time. So all that it's doing right here is checking to make sure that that little first 100 buffer is passed, and that is only going to happen. I mean, it's going to check this every time right now, but it only matters at the very beginning of when the program is running. So assuming that we're like at the point where we're drawing, after that very first time, we pass through this if statement, and I guess I should go into a little bit into if statements in the same way that while statements would run while the thing that was in between the parentheses was true. If statements will run once. It's not a loop. It's just a one-time decision, and it says, okay, I'm being asked if this is greater than this, and if it is, then what do I need to do? And in this case, return is simply a keyword that means quit. Don't do the rest of this method. Just go ahead and stop. And I guess what I'm going to do is go through this. Actually, I'm going to go through this entire method piece by piece for you and dissect it. And it may take more than one lesson, or more than one 15-minute lesson to do that. But I think it will help you understand what I'm doing. So, okay, so we ask it, and this variable here, forget about this for now. I set this, and I won't even show you where. I set it to true, and I never change it. And arguably, I shouldn't have even included it because it's a little bit of confusion. But every time we get called in that loop that we saw, it'll see that it is walking is true, and it'll go on here. And then if we're past our buffer, it won't hit this return statement. It'll go on and do the next thing. And the next thing basically says, subtract the number of milliseconds now from the number of milliseconds that was run last time and divide by 1,000. And since these are milliseconds, what this will give me is a difference in seconds between, basically give me the seconds that have elapsed since the last time this method was called. And so what do I look at here? If more than, yeah, I guess like every, what would this be? I guess that's like 1/4 of a second, which is pretty darn fast, probably even faster than it needs to be. But I'm looking to see if enough time has elapsed for me to go ahead and do something else. And if it hasn't, like, so it basically checks here, see if 1/4 of a second has gone by since the last time it did anything. If it hasn't, or if it has, it'll go ahead and do everything between these two brackets. If it has, or I mean, if it hasn't, then it'll just skip this and it'll go to the end of this and there's no more code to do. So it'll fall out, or I'll just, yeah, use that term. It'll like leave this method and nothing else is going to happen until do something gets called by that loop again that we'd seen in the main game view. Okay, so now let's assume that enough time has passed and we need to go ahead and do something. So we go in here and we set last time. I guess, you know, this isn't just the last time the method was called. This is the last time that we actually did do something. So we go ahead and set it here to now. And so that will, the next time this gets called, this last time is actually going to equal now. It'll be called in the future, but this is what allows us to continuously know how much time has elapsed since the last time we did anything, is by resetting this variable to the current time after enough time has gone by. Slightly confusing, maybe? I don't know, but that is that's how it works. So I have this method here, or this variable. I have another if statement, and I check to see if my leg is going up. Basically, the leg has two states, right? It can be going up and it can be going down. So well, I guess with that, I'm going to break and start and because we're almost to the end of 15 minutes, and I will continue up from where we left off in just a moment. Okay, see you in a second.